In this video, we're going to focus on partial derivatives. So the process of taking partial derivatives, that's partial differentiation, this is done for functions that are defined in terms of two or more independent variable. Let's say we have z as a function of x and y. Okay, so we have here a function in terms of two independent variable. So to differentiate, we can apply partial differentiation. So partial differentiation meaning differentiating with respect to one of the variables while holding the other variable as constant. Okay. So for this one, we can have two partial derivatives. Okay. Partial derivative of z with respect to x. This can be obtained by holding y as constant. Okay. Or partial derivative of z with respect to y where x is held as a constant. Okay. So these are the symbols that we usually use. Okay, so commonly used symbols are these two: partial derivative of z with respect to x and this subscript notation. This means again partial derivative of z with respect to x and some other forms of the symbol. And then for partial derivative of z with respect to y, okay, so again these are the two most commonly used symbols: partial derivative of z with respect to y, and then the subscript notation, again partial derivative of z with respect to y. All right, let's try an example. So we have here, if z is equal to xy minus 3x squared plus 4y squared, then find the partial derivative of z with respect to x and the partial derivative of z with respect to y. All right, let's start with respect to x. Again, this can be obtained by holding y as constant. So given, and then take the derivative, the partial derivative of z with respect to x while holding y as constant. This will give us, so here, first term, y is constant, so derivative of x with respect to x is 1. 1 times y, we get y, first term. And then 3x squared, derivative with respect to x, so 2 times 3, that's 6x, plus, since y is constant, then this whole term, its derivative is 0. Okay, so this is now our partial derivative of z with respect to x. How about partial derivative of z with respect to y? In this case, we will be holding x as, or treating x as constant. Okay, so with respect to y, x is constant. Derivative of y with respect to y is 1. 1 times x. X for the first term. Alright, and then since x is constant, then this whole second term will become 0, right? And then plus derivative of 4y squared with respect to y, so that's 2 times 4, 8y. Okay, this is now the partial derivative of z with respect to y. Okay. Now, how about higher order partial derivatives? Meaning, second partial derivative, third partial derivative, fourth partial derivative, so on, so forth. Okay, this is just continued differentiation, right? So again, let's say we have z as a function of x and y. Okay, we have, as we mentioned earlier, we can have two partial derivatives. First partial derivatives for this function, partial derivative of z with respect to x and partial derivative of z with respect to y. Since we have two independent variables, in this case, we can have two different second partial derivatives for each of the first partial derivatives. For instance, for the first partial derivative of z with respect to x, we can differentiate this for the second time with respect to x, or we can differentiate this again with respect to y, right? So for the first one, with respect to x, this will give us second partial derivative of z with respect to x, and then with respect to x again, or second partial derivative of z with respect to x, and then with respect to y, all right? Then for the partial derivative of z with respect to y, So we can differentiate this again with respect to y. This will give us second partial derivative of z with respect to y, and then with respect to y again. Or we can do the second partial differentiation with respect to x. So first, with respect to y and then with respect to x. This will give us second partial derivative of z with respect to y and then with respect to x. All right. Now, it is very important that we take note of the order of differentiation that is indicated in the notations used. Okay. So again, the most commonly used notations are this notation and the subscript notation. All right. So this one and this one, this one and this one. Okay. Now, for instance, let's look at uh, this notation. All right, and this one. If we use this notation here, the order of differentiation is from right to left. All right. So with respect to x first, and then with respect to y. And its equivalent subscript notation, the order is from left to right. So right to left for this one, and then left to right for the subscript. Okay, so they mean the same thing. Second partial derivative of z with respect to x first, and then with respect to y. Okay, the same thing, for example, this one, the order of differentiation again for this notation is from right to left. Okay, so with respect to y first, and then with respect to x. And then for its equivalent subscript notation, the order is from left to right. Okay, so y with respect to y first, and then with respect to x. Okay, so for instance, if we have the third partial derivative of z with respect to y, and then with respect to x, and then with respect to x again. So for the subscript notation, again, the order is from left to right. So with respect to y first, and then with respect to x, with respect to x. For this notation, the order is from right to left. Okay, so y first, and then with respect to x, with respect to x again. Okay, before we solve some examples, it is also important to note that if the partial derivatives of, for instance, z equals f of x and y are continuous functions, so in other words, continuous partial derivatives, then it can be shown that the partial derivative of z, the second partial derivative of z with respect to x and then with respect to y, is equivalent to the second partial derivative of z with respect to y and then with respect to x. Okay, so if we have z as a function of x and y with continuous partial derivatives, then we only have three distinct second partial derivatives. Okay, so z sub xx, z sub xy, where z sub xy is equal to z sub yx, and lastly z sub yy. All right, let us now look at some examples. First, we have here if z equals x times e raised to y plus y times e raised to x, then find the second partial derivative of z with respect to x twice, second partial derivative of z with respect to y twice, and then second partial derivative of z with respect to x first and then with respect to y, and then lastly second partial derivative of z with respect to y first and then with respect to x. So first one, for solution for the second partial derivative of z with respect to x given z equals x times e raised to y plus y times e raised to x. So here uh, we are differentiating with respect to x, so we hold y as constant. All right. So y is constant here, therefore e raised to y is constant. So we just differentiate x with respect to x, and that's equal to 1. So 1 times e raised to y for the first term, we get e raised to y, and then second term, again y is constant, so differentiate e raised to x with respect to x, and that's still e raised to x times y. Okay, so this is now the first derivative of z, first partial derivative of z with respect to x. And then differentiate again with respect to x to get the second partial derivative of z with respect to x. Since y is constant, the first term will become 0, and then second term, again y is constant, so derivative of e raised to x with respect to x is e raised to x. So we are left with y times e raised to x. Okay. Next, second partial derivative of z with respect to y, and then with respect to y again. All right. This time we will be holding x as, or treating x as constant. Okay. So first term x is constant. So differentiate e raised to y with respect to y. That's e raised to y. So for the first term, that's still x times e raised to y. And then second term, e raised to x is constant because x is constant. So differentiate y with respect to y, it's equal to 1. So 1 times e raised to x. This is now the first partial derivative of z with respect to y. And then differentiate again with respect to y, we are left with the first term. So again, x is constant, so derivative of e raised to y with respect to y is still e raised to y. So e raised to y times x for the first term. And then second term, uh, we have here e raised to x. Since x is constant, e raised to x is constant. Then the derivative of e raised to x with respect to y is 0. Alright. The next, second partial derivative of z with respect to x first, and then with respect to y. So we already know what's the first partial derivative of z with respect to x. Okay, just copy this one. First partial derivative of z with respect to x. And then from here, we differentiate with respect to y. So this time, x is constant. Alright? So e raised to y, derivative with respect to y, that's still e raised to y, right? And then this one, y times e raised to x. Since e raised to x is constant, then we just differentiate y with respect to y. So that's 1. 1 times e raised to x. That's why we have here e raised to x. Okay? So this is now the second partial derivative of z with respect to x first, and then with respect to y. Lastly, second partial derivative of z with respect to y first, and then with respect to x. So we already have the first partial derivative of z with respect to y. This one, just copy. And then from here, we differentiate with respect to x. Okay? So differentiate with respect to x, y is constant. E raised to y is constant. So derivative of x with respect to x is 1. We have here for the first term, e raised to y. And then the derivative of e raised to x with respect to x is the same expression, e raised to x. Alright, so we have here e raised to y plus e raised to x as the second partial derivative of z with respect to y and with respect to x. As you can see, these two are the same. Therefore, our function here has continuous partial derivatives. Okay. Next problem. If we have z equals x sine y plus y cos x, then find z sub x y, or this is the third partial derivative of z with respect to x first, and then with respect to y, and then lastly with respect to y again. And z sub x yx, or the third partial derivative of z with respect to x first, and then with respect to y, and then lastly with respect to x. Okay, so let's start. For the first one, z sub x y. differentiate first with respect to x, therefore y is constant. Okay, so partial derivative of z with respect to x, or that's z sub x, then we get what? Y is constant, therefore sine y is constant, so we only have to differentiate x with respect to x, right? And it's equal to 1. So 1 times sine y, this is for the first term. And then second term, again, y is constant. So differentiate cosine x with respect to x. This will give us negative sine of x. That's why we have here negative y sine of x. That's the first partial derivative of z, in this case with respect to x. Now, second partial derivative of z with respect to x and then y. So from the first partial derivative of z with respect to x, we now differentiate with respect to y. Alright? So first term, we have sine y. Derivative with respect to y is cosine. Okay. And then second term, we are now differentiating with respect to y. So x is constant, right? So we have here derivative of y with respect to y is 1. So 1 times sine of x. Okay. Then lastly, third partial derivative of z. This time with respect to y again. Alright. So first term, derivative with respect to y is negative sine, right? And then since x is constant, then sine x as a whole is constant. Therefore, its derivative with respect to y in this case is 0. That's why we only have here the derivative of the first term, negative sine y. This is plus 0. Okay. And then for z sub x, y, x, we already have the second partial derivative of z with respect to x, and then with respect to y, right? This one. So just copy this one. And instead of differentiating again with respect to y, we differentiate this time with respect to x. Okay, so y is constant, therefore cosine y is constant, so its derivative with respect to x is 0. Okay, and then sine x, derivative with respect to x is cosine of x. Therefore, z sub x, y, x is equal to negative cosine of x. All right.